Okay, good morning, everybody. I'm glad to see you, so many of you here. My name is Oikarinen, and I'm going to tell you a couple of things that I think everybody in the software development business should know about software security. First of all, who am I? Well, I actually started my career in software testing, security testing, functional testing, all kinds of testing, basically. And then I ended up doing almost everything you can do in an agile team. But then I sort of wanted to take a jump into the security wagon. I did some incident response, fixing or helping to fix things when there has been a data breach, when there has been a malware outbreak. And I thought that, can you do something about it earlier? And that is what I actually do here where I work in Nixu. We have head offices in Helsinki, where I actually work. We have actually offices here in Stockholm as well. But what I do, to summarize it, is that I help development teams to make more secure software. Sometimes it's hacking stuff, sometimes it's threat modeling, some techniques that I'm going to tell you today. But first of all, why do we need software security? Isn't just regular testing enough? We need software security because there are errors. Human errors, logic errors, configuration errors, things we didn't even think about. And there are actually people that are not that nice out there. There are people trying to guess your passwords at the moment, trying to make money out of your misery if you have a security weakness in your software. That really happens. So, and because there are vulnerabilities like this one that allow someone from the other side of the internet to run code on your computer without you giving them permission, without you knowing. Or because there's the exploit database, anyone can freely download code, proof of concept code, or ready-made exploits, so they can download the code, run it, and own your computers. Or because we don't want to end up in the newspapers, like you did a couple of years ago with the big data breach. Well, we in Finland didn't do much better either. This is from last year. There was a big leak of plain text passwords. Come on, it was 2018 and plain text, come on. Or like British Airways, they outsourced their payment stuff, which is a good thing to do usually, but someone was able to tamper with the code. A lot of credit card details were leaked. That's why we need software security. And we talk about, as security consultants, building security in. But what does that mean in practice? If I would ask someone about software security, they would probably mention patching, and then pen testing, and incident response. So testing things when they are pretty ready, and fixing things afterwards. But you could start earlier. You could start by building security requirements to try to analyze what is the level of security you need to aim for, and do threat modeling to find out what is the bad thing that could happen, and then try to mitigate that. And there's so much more. There's something for every step in the software development lifecycle, something security related you can do. And just to make one point clear, security people, security consultants, auditors, pen testers, whatever title they have, they are not here to stop you from doing your job. We don't want to annoy you, we don't want to embarrass you, we don't want to laugh at your code or anything like that. We just want to find security weaknesses before someone with bad intentions finds them. That's why we're here. The next thing I'm going to show you is sort of something that you can cross out of your bullshit bingo. I just couldn't resist on drawing a Venn diagram. I know it's kind of like C-level corporate stuff, but I think it's really well depicts the three things I want to talk about today and how these things are related. I want to talk about security requirements, threat modeling, and how you can do security testing. Starting with security requirements, how to create them, how to select them, how to pick the right level of security. I mean, if you are creating an application that allows you to check bus timetables, it doesn't have to be as secure as an online banking application or something securing a power plant. So that's different. So the first thing you should ask yourself is that what is the data and important assets that you want to protect? Is it the data that your end users enter into your system? Is it your marketing database, your customer database, or the secret sauce that gives you competitive advantage? Or is it your server resources? Probably you want to run your services on them and not some cryptocurrency miners. Maybe it's all of these things. Also, you should know what are you made of? What is your application made of? Like libraries. What kind of open source libraries do you use? What kind of dependencies they have? The dependencies of the dependencies. Can you track the known vulnerabilities in them? Or do you have your server resources on premise, on cloud? How many servers do you actually have? All kinds of things to know what you are protecting. Then you can try thinking about the threats. One technique you can use for creating security requirements in your system, in your application, is evil user stories. It works by completing the sentence, an attacker should not be able to what? If we have an online shopping site, an attacker should not be able to purchase items without paying, for example, or they should not be able to hack the site using known vulnerabilities. Or users, regular users, they should not be able to see someone else's personal information, right? Or a user should not be able to send spam on the contact form if you have one on the site, and so on. Or many simultaneous users, they should not be able to make the site crash, which unfortunately happens very often when there's a popular band giving a concert and everybody wants to buy the tickets at the same time. That's reality. Or about the admin user, they should not be able to accidentally shut down the site without no confirmation. These kinds of things are evil user stories, and what makes them stories is that you put them in the backlog with mitigations as the acceptance criteria. For example, the user should not be able to send spam. What you can do about it is that you can have rate limiting. So you cannot send just at any speed possible. You limit how often the API queries are made. Or you can have a CAPTCHA on the form. And you can validate input for if someone is trying to enter SQL injection clauses into the feedback form. It's not probably going to be very constructive feedback. You might want to just put it in the trash. So what you have in the backlog then to consider this feature to be finished, you want to have implemented rate limiting, you want to have input validation implemented, and some security testing done. And then one thing to remember about security requirements, that please don't reinvent the wheel. There's a lot of security standards and good material out there you can use to kind of fulfill the application-specific part that you just created with the evil user stories. For example, if you're creating web applications, there's the OWASP. OWASP Application Security Verification Standard. Well, that's a mouthful. ASVS for short. It has requirements what you should have about session management, authentication, input validation, crypto, so on. How you should do it with actual examples, and then how to verify that you have made it correctly. There are different levels. Level 1 is something for very basic applications. Level 3 for very secure application, and level 2 something that you should probably aim for. The OWASP top 10 is a kind of subset of ASVS, the 10 most common blunders in web applications, so please check at least this. Similarly, for mobile applications, there's the mobile version of ASVS. It has, again, instructions, what you should have. examples included, and then also how to verify, how to test that you have done it correctly. If you're doing IoT stuff, there's the OWASP top 10 for IoT as well. I think this material from UK government is pretty good as well, what you'd have in consumer products. But then you might be thinking, what if I do something else? I don't do mobile apps, I don't do web apps. Well, the good news is that you can use the material from ASVs. Okay, maybe now you don't have cross-site scripting or something like that, but still, if you're accepting input from users, you should validate that, maybe look for operating system command injections. Or if you have login, you should check for authentication and access control issues. If you're connecting over the network, you should protect the data in transit and so on. So you can use this material. The next topic that I wanted to talk about is threat modeling. The basic idea is that you think what could go wrong and what can you do about it. You have probably done it already in a way or another. Let's think back when you last time you had a vacation, you traveled somewhere. You're thinking about the location. Is it safe? Do I want to go there? Is there something interesting to do? Is the weather nice? Not too hot, not too cold? If you're taking your family with you, you want to make sure that there's something interesting, even if it rains. Then you may be thinking about the food. Should you avoid some places? Can you drink tap water? You don't want to get diarrhea for the whole week. So you think what could go wrong and you have precautions like washing your hands. So that is threat modeling. Or you have travel insurance in case of lost baggage or pickpockets. Again, thinking what could go wrong, having precautions, that is threat modeling. Okay, probably you're more interested in threat modeling software. I'm going to give you examples about that next. But that is the idea. And one thing I really like about threat modeling, and that's why I encourage you to do that, is that you can do it really early in the design phase. You don't need to have anything implemented yet. You don't need any source code. You just need an idea of the features that you're going to have in your application, and maybe a sketch of the architecture. If your system is more ready, you're about to release, or you're purchasing another system, integrating to a one, you can use threat modeling to target testing, security testing, to the most risky parts of the system, so you can test them first. And also, testing doesn't find all weaknesses. It's really hard testing things like your software development process. Does it have any weaknesses? Or you might not have all the time and money in the world to test the whole system like in a very detailed way. So you might need to focus on something. And some like logic errors, they might not come up with testing in the testing you do. So that's why threat modeling is good. Also, threat modeling helps us to identify what threats are relevant to our business. Think about a minute the images and words you see and hear about cybersecurity threats. A lot of pictures with people in black hoodies without no face. There's talk about advanced persistent threats, nation-state hackers, botnets. It's kind of dramatic sometimes. I know, I'm sorry about that. But if we are an online shopping site, instead of a power plant powering up our whole nation, our threats are a bit different. For the shopping side, it might be really relevant that some bored script kiddie with 15 euros buys a botnet and runs a DDoS attack on your site just for the fun of it. It happens. Or cyber criminals are constantly looking vulnerable computers and showdown. They don't care actually who you are, but if your computer has a weakness, they can exploit it, put ransomware on your computers, and ask you for money to open it up. They were solely do it. And plain old mistakes, configuration errors, that's a threat. One typo, you can create a denial of service on yourselves without any help from script kiddies or hackers. And then how to do threat modeling. Well, you can have a workshop, reserve 2 or 3 hours, invite everybody who knows about the system. And this is another other thing that I really like about threat modeling, because you can involve almost everybody. Testers are usually very good at this. In my experience, they usually know how the system works, and they have the best knowledge of it. They're using it constantly, and they already have the right mindset of thinking of corner cases and evil stuff and how to do weird stuff and how would the system respond. Developers or architects, of course, know the system on source code level. If you ask them, or you can tell things like, are you validating input on this API, or how do you store keys? And you might find weaknesses already by asking a couple of questions. Product owners or project managers are a good addition, because they can act as a link between the development team and the business. The business might have a big fear that, okay, we don't want to get out of business, we don't want any GDPR fines or something like that, and then you can figure out with the technology information that could that threat happen somehow? Is there a way of that could happen? Or vice versa, if you find out the weakness that you need extra time and money to implement that mitigation before you release, you might need to explain to someone why is that important, and the product owner can help in that, explaining that, okay, if we don't validate the input in this context form, we might end up with cross-site scripting, and people might steal some information from our site about our customer, and that's really, really bad for our business. So there you go. Then it's also useful to have someone with a broader knowledge of security threats. What is the threat landscape at the moment? What could be considered a weakness? What other businesses do usually? Is there a problem with your architecture, and so on? Then the when part. As I said, you should do threat modeling pretty early as possible to map out your attack surface. Where are you vulnerable? But then sprints after, if you are redesigning the system, adding new features, modifying them, removing them, your threats might be totally different, so it's good to check the threat model if it still holds, and can you live with the threats and the risks. And then the outcomes. Well, you can file bugs or backlog items directly if you find out that, okay, we are storing keys in a plain text file and everybody can access that basically. Hopefully not, but as an example. Or you can create test cases of the threat scenarios that you come up with, so you can keep testing them sprint after sprint and see if that you are secure. And you should document the whole thing, the threats you find, also the threats that you brainstorm, but then you think that it's not relevant. Like if you think that the NSA will infiltrate our systems and own everybody, well, yeah, that could be possible. Not very likely though, so you might want to skip that. So when you're checking the threat model, you don't probably remember that after all these months, so you can have the documentation why you ended up in this solution. About the results a bit, you can of course list the threats you find, but you can try to map them out, visualize how they are related to each other. Let's have an example of the online shopping site again. If we have a login for each customer, if someone guesses the password, what happens? Well, it could be that someone is able to log in as that user, impersonate them, and see everything that the user has entered in the system, everything visible in the profile, like their purchase history. Another threat is that there's a vulnerability in the server components, and if it can be exploited, it's possible that the web server is compromised. Again, you can see information about users, maybe this time about all the users and not just one. Also, someone could plant malicious JavaScript on the site, so everybody who visits the site gets malware, or they're mining cryptocurrency while they're on the site. And if I was that user, I got malware, my information was stolen, well, I'm not going to use that company's services again, ever. So that's loss of reputation at least. And we've seen that data breaches may lead to a drop in share price, at least momentarily. So this kind of maps out what can happen if one thing goes wrong. Next I'm going to show you a couple of threat modeling techniques, how to find threats from your features and your architecture. And first about user stories or features, you can think, is there something dangerous or permissive, like being able to see every user in the system? Let's say your company has a portal for exchanging documents and contracts or reports with your customer. If every customer is able to see every other customer, that might not be sort of, they see who else are you working with, and that might not be public information in all cases. Or if you're able to upload files, if you don't restrict that in any way, it could be dangerous. Someone could try uploading malware. Or viewing health records, revealing potentially sensitive stuff. So you should be able to check that only the right people can access that information. No one can bypass the access controls. Maybe you need multi-factor authentication and not just a password. And you should have logs of, you can map out later who saw that information. Then admin interfaces, they are usually permissive by nature. You can modify files or user accounts, start and stop services. Again, you want to make sure that only the admins can access that interface and not just anyone. Maybe you need multi-factor authentication again. And logs, was it Peter who made that change, or was it just some anonymous admin? You want logs. Also, there can be combinations of user roles that are sort of dangerous. For example, if you're filing expense claims, like if you traveled here from a long distance and your company pays for it, you make a claim. And then if you're able to request it and also approve it, and if it's worth a lot of money, like some company expenses might be, if they're being billed for someone else, so you can. It's not always a good idea if you can both request something and then say it's okay. So you might want to technically limit that no user can have both these roles or have a manual process checking that regularly. These are the things that you can ask yourself with the features. Also about the architecture, there's a model called STRIDE, which is a very thorough method of checking the threads you should have in the elements of the architecture, like the web server or log server, and the connections in between. Each letter comes from a specific thread. S means spoofing, so you can spoof a person, try to log in as someone else, or you can spoof a server. Man-in-the-middle attacks are actually spoofing a server. Like, you have another server that you try to lure people into connecting to, and then you pass the traffic to the actual server. Or tampering data, tampering logs. When I test web applications, what I do is that I have proxy. I tamper the data using it before I let it go to the web server, insert in evil stuff and try to see what happens. Or then repudiation. It means that someone is able to deny that they didn't do something. They didn't log in. They didn't make that change. They didn't buy that insanely expensive TV and I want my money back. So, denying something. Information disclosure, well, leaking stuff out. It could be some too much information in a server error message, Or by tampering, if you're able to do SQL injection, you might be able to spill out the whole contents of the database. That would be information disclosure. Or if you don't encrypt traffic and you are able to intercept that. Denial of service, too much traffic, too many users at the same time, memory full, disk full, a condition that makes the system unavailable or very, very slow to use. Elevation of privilege, getting root, being able to do something that wasn't meant for your user role. If you are just a regular user but you can do admin stuff, maybe sometimes just adding /admin at the end of the URL and you magically get to the admin interface. So you can combine these two techniques, taking a look at the features, taking a look at the architecture. You can analyze the data flow, what data you have, where does it go inside the system and outside the system. If you have swim lanes or other sort of diagrams or just the architecture, you can trace out where does the data go. I have an example of this, again about the online shopping site, buying a book. Let's start with the browser and the user interacting with the server. Things you can ask that, okay, is this user authenticated? If there should be, logged into their account? Or could they be able to spoof somebody else by on something on someone else's account? Can they bypass access controls? Is the traffic encrypted, by the way? Can somebody see all the traffic that happens? Can you try to inject evil stuff? If there's a form, you can enter numbers and text. What else can you put there? Or can you try to buy a book without actually paying? That's a threat. What about denial of service? If someone wants to run a botnet, what happens? Do you have enough resources to handle that? Then probably the web server fetches something from a database. Again, is there mutual authentication between the servers? That could be important if there are other servers in the same LAN segment, and if there's a breach in one of them, or maybe the web server, they could be able to access the other systems without extra authentication, without knowing any credentials if there's no such check. Or maybe the user, the original user, can get a purchase history on their account. But would you be able to list everybody else's books if you just modify one parameter? Or again, can you try to inject evil stuff to the database? Or what happens if the sorry about I have flu. What if the database connection is lost? Do you even show at least a meaningful error message? Or does the system crash and show a white page or something like that? If you have a database, you probably have a database management system. Could an evil shopkeeper be able to tamper the database and modify the delivery addresses maybe, so they get all the books instead of the ones who actually paid for them? Or if they are able to do that, does it at least leave a log entry so you can take a look later? Anyway, all the user actions, admin actions, do they leave a log entry? Because they should. But they shouldn't contain personally identifiable data. Could be a threat. And most importantly, does someone even take a look at the logs? There's no little point of having them if you don't monitor them. Also about the attack surface, usually you focus on the outer rim, what you can access from the internet, what the user does, the user interface. But you have probably connections to internal systems, like the log management system, database management system. Yes, they might be totally internal to your company, but who can access them? Do they have any sort of credentials? How do you store these credentials? There could be possible attacks coming from this way. Also, any APIs you have. Again, do you protect the data, the credentials, the data in transit? Things to look for, so just don't remember to look for all interfaces and APIs and not just the user interface. Then a couple of words about threats in software development processes. As I already mentioned, it's really hard testing those, but you can sort of brainstorm and go through them, what happens. Think through the whole chain when you code with the keyboard to when the actual code actually ends up in production. Things that you can ask yourself, starting for about package sources and their integrity. Do you know where you downloaded your packages? Do you know that nobody tampered with them? Are they the real thing? There has been several cases with NPM with typo squatting. Typo squatting means that there's a package with almost exactly the similar name as the original package, but a small change, like a one hyphen, and because you don't exactly remember what the package name was, you install accidentally the wrong package. And it works fine, except it has something extra. That extra is usually spying on you, or it has malware. So you want to make sure that it's the right thing. Or are you able to detect known vulnerabilities in your software? If you're using a ton of libraries and they have transient dependencies, you cannot track them with an Excel or something like that. You need tools. I will mention actually a couple of them later on. But if you don't know if there are vulnerabilities, that it could be a severe threat. What about code quality, the code you make on yourself? Are you able to tell that it's right, that you haven't forgotten to do something? You cannot, in some cases, bypass authentication, or you're not leaking out stuff. Things like that. And how do you make sure? Do you have like security reviews, somebody else, your colleague, checking that for you, or do you think it's fine and just push the master? Or what about storing credentials, the API credentials, or any other keys you need, certificates? How do you store them? Would someone be able to access them? And if they can, what happens? In all cases, it's not a problem, but it could be, and you might think through the scenario. How can you change those keys later if you need to? What about source code and CI? It's good to have your system so you can access them everywhere. So like using Bitbucket or Jenkins without VPN. But what if someone guesses your password? Is that all that is needed to get the source code? What can someone else do about it? Does it contain secrets? Will someone be able to modify it, commit? Would it end up in production, or what kind of steps would it take for that to happen? Or the systems that build the application, would someone be able to tamper with the build and add something there? Other questions to ask about your test environments and test data. People usually get really annoyed if I ask that, do they have a separate testing environment? But I think it's a thing that I need to ask, because it's not always like the certain thing. It's good to just test something else than in production. And also, where does your test data come from? Does it come from production, or have you generated it so it doesn't contain like social security numbers? Do you do security testing to make sure that it hasn't got any weaknesses? Do you do any testing at all? Or what about the manual steps in your deployment chain? If you have a lot of manual steps, there's so many places for human error or typos or mistakes, and then something could go wrong and the build might not work, and you end up with non-functioning system application in production, which could be sort of at least a lot of corrective things to do and not nice. Or are you following the procedure always? Always? Even if you need to do a hotfix, do you skip some steps, extra validation, because it works every time. It will work now. And logging and monitoring again, would you know if your server goes down? Would you know if someone else logs in? Would you notice if there's an anomaly? Things to ask yourself. What would happen? Then a couple of words about privacy. This is like the minimum viable privacy. Really, if you're unsure, ask a privacy expert about these things. But there are two things that everybody should remember to check. It's the logs and test data. First of all, are you logging personally identifiable data? After all this GDPR thing, you probably know that it's not a good idea. Sometimes you need to do it. Then it's important to secure the access that only the right people can see that information. They probably need NDAs and all that. And if your system contains personal information and like an admin needs to access sometimes the user accounts, you should have a log that who has accessed this information and when and why maybe. Regarding test data, did you copy the test data from production? Okay, if you did, the level of the test environment security should be the same as the production environment security. And again, who can access that? Usually the production can be operated or accessed by a slightly different set of people. So other people access the testing environments, like external consultants, like me, could be accessing that. And well, I don't want to see anybody's personal information. It's good to have, like, if you cannot generate it from the scratch, you can scramble the production data. But again, if you can reverse the scrambling, you end up with the exactly same production data again, and there are linkability issues. So things you want to check. So to summarize, threat modeling is good for finding weaknesses early when you only have the idea what you will do, and you can target pen testing based on the risk. And because it's hard to test everything, you can brainstorm what would happen and find weaknesses elsewhere. But know what? We have security requirements now, like what is the level of security we should aim for? And we have identified threats and mitigations, but how do we verify that we have done it correctly, that our implementation is secure? And that's why you can do security testing, and emphasis on you. You can do it. You don't need to wait for somebody external to come and do pen testing. Of course, it's good to have maybe an external source that isn't like objective, but still, you can do a lot yourselves. And I really can't emphasize enough that you should do testing early. Find easy stuff with automatic tools, even if the findings might seem low or the tool reports that it's low level and easy stuff. Don't overlook them. They are still relevant. Find the easy stuff, fix the easy stuff. Because if someone wants to attack your system, they won't bother creating a complicated exploit. If there's something really easy, like they can use a default password, why not? So it's important to do security testing and also fix the issues that doesn't seem so lead hacking, because it's important. So what you can do is you can track your dependencies, check if you have known vulnerabilities in your source code. There's a good open source tool called OWASP dependency check. You can use that. There are also many commercial tools available. If you want to try them, I suggest that you pick 2 or 3 and then have a trial so you know it works with your systems, your source code. Commercial tools can usually detect also license issues, like if you have Apache license and MIT license and GNU license, you cannot mix and match everything. So they will tell you what's okay. Also, code quality checks in the code that you write on your own. There's a caveat that these tools probably will report a lot of false positives, things that are actually okay, but they will tell you that this is not good, you fix that. Also, they will have false negatives. They won't detect every security issue, but still they are pretty useful for at least for other quality things, and they will also find some security related things. But they will not replace a security-oriented code review, but like some actual person taking a look at your code, the security-related stuff like authentication and logging, all that, and check if there's a problem. Also, these are highly dependent on the programming languages you use, so you need to trial them out, which works for you, then don't just blindly buy something. Then you can test your applications. There's a free tool called OWASP Tap. You can scan automatically your web applications and mobile applications. It works as a proxy, so you can sort of record what you did and then replay it. It can also be pretty easily automated with Jenkins, for instance. And that's Burp Suite. It has a free edition, and it's Pro Edition, which is like the hacker's choice for manual security testing. Very powerful tool. It isn't actually very costly either. The Enterprise Edition is more easily integrated with CI. Then, if you have SQL databases, I really recommend trying SQL Map, another free tool. It can help you pretty easily detect and also exploit SQL injection vulnerabilities. Well, exploiting is not necessarily unless you need to make a point to your boss that, okay, we really need to fix that. And use it under your own systems, by the way. Did I already mention that? Not somebody else's. On network level, you can kind of easily check things like lack of security headers or insecure TLS algorithms. The tool I like to use is test SSL SH. I think somebody yesterday mentioned SSL Labs, but you can use both, and this is actually something that you can download from GitHub and use on systems that are not available on the internet. And for checking open port or network segmentation, you can use Nmap, another free tool, a very useful tool. So you can do security in every step of the development lifecycle. You don't need to wait until the end. You don't need to wait for an external security consultant to do that. You can do a lot of that stuff on your own, and you can do a lot of that stuff without having anything implemented. You can work in the design phase also. And that's all I want to say. Tack att ni lyssnade på mig.